Guys, so this is another emerald doubt. So you can go through this question. There was a heavy rod which is suspended in the way, and your string on this side is snapped. This is the rod, this AB is the heavy rod, and those are strings. So typical JEE style, we will take it as inextensible strings, and what they are saying is that the rod has got accelerations AY, you have AX, and the rod has got a certain rotation. So with respect to the center of mass, it is pretty safe or right to assume the rotation this way. I'll just make it again. If this is center, you have got a certain rotation alpha, and they are asking to relate this AX, AY and alpha given the length of the rod as L. So with respect to the center of mass, why is the alpha that way? Because if I look at the rod, I have got a tension this side. The tension has got a component in the vertical direction, and which is going to provide it a torque with respect to the center of the rod, and that will be the alpha that way. So we have our directions set over here. Now, as I said, inextensible string is what we are going to take. So one side is snapped. We are not going to say that this side is recoiling or something. It is going to be taut, and if it is going to be taut, it is going to go and take a turn while it is taut. So this string length, I call it as R. It is at 30 degree right now. Say string length is R. Then this point A of the rod is going to have an acceleration of, say, the string rotates with alpha dash. So this acceleration this way is going to be R alpha dash. So that's the actual acceleration of the point A. Now let us just see the acceleration of the point A with the variables what they have provided, which is AX and AY and all. So your AY is how much the rod goes down. So we'll see that this point A is having what acceleration? Actual acceleration. The actual acceleration downwards would be the component of R alpha. So if you make a horizontal, this angle will be 30 degree again. So this will be 30 degree, and hence it is R alpha dash into cos 30. So I'll just write it as root 3 by 2 over here. And the acceleration in the horizontal direction is R alpha dash sin 30. So R alpha dash divided by 2. So what is this R alpha dash divided by 2 and R alpha dash root 3 by 2 in terms of AX and AY? So clearly the rod, I'll just draw the rod again over here and look at the rod. The rod is rotating with alpha with respect to the center of mass, and it is going down with AY. So this point of the rod, which is point A, is going up with L by 2 times alpha, and the whole rod is going down with AY. So the downward acceleration of point A is AY minus L by 2 alpha, which is equal to R alpha dash root 3 by 2. So that's your equation number 1. So we need to write the horizontal also in terms of AX. So horizontally the tension is pulling it on the left side, so we have a horizontal acceleration of AX. Due to that, according to in our alpha dash terms, that AX is straight away equal to R alpha dash by 2 is your AX. So we just eliminate R alpha dash by 2. So R alpha dash by 2 is AX. So I can write that in equation number 1. This R alpha dash by 2 as AX. So I get AX root 3 is equal to AY minus L by 2 alpha. So this would be the relation looking at the constraint of the question. So it would be quite interesting for you to write down the forces and write down your equations of torque and all, and explore the question more. Thanks a lot.